Okay, John actually asked me to do this particular talk that I've done before, so you can all ask him why LugRadio didn't know what talk I was doing and why it's not on the programme. It's a talk I originally did in Ireland about all of the things which happen which don't involve the programming side. So hopefully it's more generally relevant and useful than the innards of serial ATA drivers. In the business world, which is where some of us live even in the free software world, we have all of these people. We have managers who create work and get in the way and allegedly manage things. We have marketing people who promise things you can't deliver and then scream when you tell them you can't. We have translation people who spend most of their time trying to explain that Google Translate is not a usable solution. Technical writers who spend their time screaming at the programmers asking where the documentation they need has gone. QA and testing people. In certain companies these appear to be optional. I'm happy to say in Red Hat we have QA and testing people, and I get beaten up regularly by them when I break things. Support. That can vary between a real support system, a bunch of people on the end of a telephone. Some of the people on the end of the telephone might even know what they're talking about. Accountants, because the shareholders matter. Customers might matter too, that's a questionable point. And occasionally you train people. Although usually, certainly in the software business world these days, the accepted policy appears to be to wait for people to move to another company. And the open source world is a bit different. Not entirely. We have less managers on the whole, because if you've got a manager who isn't needed, he gets ignored. If you've got a manager who doesn't know what they're doing, they get ignored, and they generally go away after a while. There's lots of wannabe managers turn up. You may have noticed every so often on mailing lists, someone turns up and says, I've got this great idea for this piece of software, blah, blah, does this, does that, does the other. All I'm looking for now is some people to program it, draw the artwork, and let's have a logo competition. So occasionally we get management people turning up. Marketing. There's a huge amount of marketing goes on, and I'll talk about that a bit more. You only have to look at things like the work Ubuntu is doing to realise that there's a huge amount goes on which is not necessarily commercially oriented, funded marketing. Translation teams. Lots of projects have got translation teams. Translation teams are all over the world, which is a huge advantage to trying to translate something when you're doing the translation in your sort of home country and exporting the results, which normally produces much mirth and hilarity when it arrives in the destination country. QA, testing, some of that's done by shipping it and seeing if it works. Some of it's done on a more formal basis, depending on the project. Huge internet-based infrastructure, and people have to keep this stuff running. Kernel.org doesn't run by itself. And things like Newbies Project, which is the training side. Drawing people in, teaching them how to do stuff, whether it's kernel hacking or just basic C programming. Some of that's kind of free software driven and open source. Some of it's very much commercially driven on the back of it. As you'll notice, there's an O'Reilly stand outside. Right. Oh, it's nice. Great. It's decided to format my slides wrongly. Which is interesting because it formatted them correctly when I tested this morning. Okay, something I want to start with, because it's something you hear from a lot of programming people, particularly programming people under about the age of 21. So there's two kinds of people. Those that can code, they do everything wonderful. They write all the software, they pick locks, they do cool hacks, they invent wonderful pieces of technology. And those who have no use at all, known as everybody else on the planet. It's a wrong, incidentally. So, what do we do about all these other people? On one point, what do all these other people want to do anyway? Can we do useful, help with projects, make things happen, do cool stuff? Well, if you've ever written a piece of free software and put it out on the internet, one thing you will notice users are really good at doing is breaking it. So you can write a piece of software, you can use it yourself for 3 months, put it out on the internet, and 2 days later you'll get an email from someone saying, I typed this in and it went bang. Or I pressed this button and something funny happened. All of this stuff is really useful, especially when you find someone who's got a system or a data file which reproduces the bug. For example, people working on things like PDF document viewers, one of the things they most like to receive is a PDF document which crashes their program or renders wrongly. Because actually having this kind of reproducible case is the really, really valuable stuff. As a developer, you can't spend all day feeding every PDF document on the internet to your software. You can automate it a bit, but only so far. Users effectively do this. Even more useful, from a statistical point of view, users test the most commonly read documents the most. So in theory, they will report the bugs which affect the most people more often. So not only do they find the bugs for you, they prioritize them. One of the problems, of course, is the kind of bug reports you get. Because people who don't really understand bug reporting, there's several mistakes people make. One is that they assume that the exact text of messages is not important. So you get bug reports like, I loaded this document, it said something, and the window went away. Great. Whereas I loaded this document, it said file blah blah invalid assertion at line 914, which is what it probably said, would have been much, much more useful. Programmers don't help this. I mean, to be fair, if you're a developer, you've got messages you want users to report, make them clear, make them short, and put them in something approximating plain English. Because end users are frequently quite lost when it says something like Wombat 314 and the program crashes. And people do things like this. Their bug macros print the most bizarre and wondrous things. If it prints something like such and such has failed, brackets, some number, please report, you've got a much better chance of actually getting feedback. Similarly, if you're trying to report bugs into Bugzilla and stuff, try and give the exact text of messages. If you've got something like the kernel crashing and you've got messages on the screen you can't copy or save anywhere, something which is increasingly becoming common is people are attaching digital photos of crash dumps. Because particularly if you're working in a real-world environment where you need the machine back up before the boss kills you, being able to just take a digital photo, then reboot the machine, means you can grab the dump data, report the bug, carry on. Similarly, if you get graphical programs displaying in really weird and wondrous ways, sometimes a digital camera photo of an LCD display can explain what's happening. There's another really, really important reason that people who are not programmers are really useful. One of them is they don't understand what is perceived to be hard. It's a thing called beginner's mind in some areas of things like philosophy, which basically, because no one has ever told them that something is hard, they're happy to have ideas which programmers would instantly dismiss, say, oh, we could do that, but it doesn't make sense, without necessarily realizing that there is an easy way to do it or that there is a way it makes sense to do it. So a lot of things which get dismissed and never thought about by developers actually come up from end users saying, why don't we do that? And the programmer going, well, you see, it's hard because, hang on a minute, let me send you a patch. Marketing. The most important marketing information you get from anybody, business, non-business, whatever, is stuff from people who actually use the software. Preferably people with no commercial interest. It's why in business people are so interested in the blogosphere and are making such a hash of blogging their product and all this other crap. It's why companies spend a lot of time trying to give freebies to the right people to tell everyone else, this is a really cool television or whatever. And there are certain people they give these things to. And it comes from people in related fields. In other words, if you are working in part of the software industry and someone says, we've installed this new web server, it's really cool, and they do web server development and they're friends of yours, you will trust them a great deal. If they're the marketing manager, you might be a bit dubious, thinking, what's he bought this time? But then you might phone up their programmers and ask. Whereas if you see an advert on the internet saying, our product does huge list of things, Microsoft Foo is faster than anybody else's Foo, this report sponsored by Microsoft, you get suspicious. So the people who are most important are the people using this stuff, developing it, working with it. Everybody. Things like a Linux distribution are not just judged by the people who go out there and say, I am an Ubuntu evangelist. I do Ubuntu marketing. Every user, everyone who posts to a mailing list something stupid, everybody who, when they try and set up a women's group, makes sexist comments, all of this has an effect on the way the product and the way the software and the way the project is perceived. So all the bad things and all the good things. That's very important to realise if you're involved in some project like that. Because some things you do stupid that piss people off will be remembered. And yeah, we've got marketing people, we have evangelists. It's actually quite interesting to look in the business world because the free software world invented this idea of evangelizing rather than marketing a product. Because marketing is a nasty, rude word and is associated with all the bad things that programmers don't believe in. At which point the marketing people thought, evangelists. So if we call ourselves evangelists, they'll believe us and we'll be like cool and hip. At which point everyone in the free software world think, oh my god, and went back to calling themselves marketing. So the only people now you meet with the title of evangelist are things like senior evangelist for Java at Sun. And it says everybody else in the free software world running a mile. Translation teams. There are several thousand languages on the planet, 200 and something countries, and an awful lot to translate. Contrary to common opinion in certain parts of the world, most people do not speak English. In fact, there are languages which have been added, particularly some of the Indian languages where support has been added, where when you add support for these languages, you add 1 billion people to the list of people who can use your software. Similarly with Chinese. So you go from a few 100 million English speakers, good, bad, or indifferent, to 1 billion people for this language, a couple of billion for that language, and the English-only mentality starts to look silly. One thing translation does require is language skills. Really, it needs somebody who is good and fluent in a language to do the translation. I mean, this part, in some ways, is often more relevant in the rest of the world, because it's very rare we get a piece of software which is not in English and has to be translated to English. There are been one or two exceptions. Things like Sylpheed started off pretty much entirely documented in Japanese. But in most parts of the world, it's a very important thing going on. The other great thing which goes on with translation, when you try and translate software, you have to understand what the original text means. When you read the original texts of a large amount of software and the messages that they print, and you're reading it with a kind of your thinking hat on, rather than just glancing at it, thinking, what is this dialog box trying to say? You start to notice some truly, truly terrible original text. And it's only when we translated some of the Red Hat installer that somebody noticed, for example, that it said, if you have a sound card on your computer, which is an interesting idea. I thought you put it in the computer to get it to work. No one had ever noticed. The moment people started translating, somebody immediately actually read it properly. Sound card on computer, that means file bug. It's been there for several years before anybody noticed. It needs consistency. One of the things that translation requires, and in some ways one of the things that it's a good idea if you're not translating, is common terminology. What is a window? When is it a dialog box? When is it a window? What do you call your toolbar? All of these kind of things throughout a program. Is it a menu? Is it a list? Is it a dialog? Is it a selection? All of this kind of stuff, if it's consistent in the program, makes it easier for people to use. And that's something you don't need to be a software developer to work on. It can be very hard sometimes to understand why something doesn't feel right when it's consistency. And it's only having an eye for design, which is not necessarily the same thing as writing the software, which is important. And font design and rendering. English text is kind of easy to render. You start on the left-hand side, you work right. All the letters are roughly the same size, they go in the same position. As soon as you hit other languages, it gets more fun. Some of them go right to left. Okay, not a big deal. Some of them go right to left, but put English words left to right. So if you're writing in Hebrew, for example, and you quote an English phrase, the Hebrew goes that way, the English goes that way, and the Hebrew carries on. If you're writing Arabic and many other languages, when you have a vowel, it has a symbol. When that vowel has two consonants either side of it, it disappears and becomes a mark. So you have to deal with this in your editor. So you're typing away, and each time you hit add a character, it doesn't necessarily make the line a character longer. And there are languages where some letters are half the width of others, or twice the width of others, and these are precise rules that must be followed. So a lot of work has to be done on that. And the good things is most of it has been done with things like Pango. So translation is a really, really important thing, which needs people with the language skills to do it. And generally speaking, the people with the language skills and the people who are programmers don't overlap. Occasionally they do, but quite often they're very different groups of people. QA. QA is hard because the people out there are so devious. And if you tell someone how to use your software, they will find so many different weird and wonderful ways to use it wrong that they will eventually break your software. So how do you do testing? Well, one of the things you do in the business world is you do regression testing. You test all the things that have broken before. Typically, you pay some poor guy in India to go through 150 different menu operations, one after another, ticking boxes. We can't really do that in the free software world. So instead, we ship it. And 150 random downloaders go through clicking all of the boxes they use and break it. But we do some testing, and you could do a lot of testing, get a lot of benefit from the fact that there are lots of people using, for example, early releases of software. I mean, things like Fedora are partly that. And because Fedora is testing new and greatest releases, it produces a lot of bugs which go back to people who wrote the software and the packages, saying, we tried your latest, greatest version, it's really cool, but. You want lots of tests, lots of hardware, lots of different combinations, lots of people figuring up interesting and different ways to use the software. Which, of course, giving it to a large user base does, so long as they report it. There's also tools. It's no good if all the users find bugs and nothing happens afterwards. So you need to track them. Things like Bugzilla, Track, these kind of systems. And they need to be easy for end users to work, which Bugzilla, unfortunately, in general cases, not. There are tools like Tinderbox. So people who are developers find out they broke the code very rapidly and get told off for it. There are various other testing tools that turn up. Debian is another one, because they compile software for this ridiculous range of machines. So every time you write a piece of user space software and you get the portability wrong, somebody at Debian.org will eventually mail you saying it doesn't compile on an ARM, or it won't run on my VIC-20, or whatever else. Standards compliance. This has been one of the most boring jobs I know. It involves spending hundreds of hours arguing with people about the interpretation of paragraph 34 of clause 12 of how the ls command is meant to work. There are people who love it. There are people who spend their entire life tweaking Linux software to be strictly standards compliant, and upsetting other people who think that actually that's the wrong interpretation of strictly standards compliant. There are people who actually work on things like the POSIX committees. I mean, Ulrich Drepper, who works on glibc, is heavily involved in the standards committees. So if you like test suites, if you like arguing over fine details of language, and if you want a job which is both useful and involves complaining and criticizing without writing any code or doing anything productive, standards compliance testing is your job. It's an entire career in arguing, complaining, and giving other people work to do. People we shouldn't forget. Every single free software project runs on something. Web servers, FTP servers, translation systems, mailing lists, FTP archives, people who organize things like all the BitTorrent feeds, build systems. There's a huge IT infrastructure out there. Most of these people are actually forgotten. So you can sort of say, who wrote the Linux kernel? Oh, Linus Torvalds and blah, blah, blah. Who runs kernel.org? See? Yeah, people who run kernel.org are pretty important in the big picture of things, because without kernel.org we wouldn't get a lot of work done. And we know this because there were free software operating system kernels around well before Linux, and they all died because there was just no way, no infrastructure to get copies out to everybody, to share it, to build on it. Mailing lists, well, mailing lists take an infinite amount of time to operate, maintain and run. Keep all the spammers out, investigate what the latest automatic sign-up robots have discovered. I mean, one of the things that's happened recently, for example, well, it's about a year has been going on now, is that people with mailing lists have been using this stuff where it puts up a little picture that says, type the word you can see in this picture to eliminate robots. So what the spammers have been doing is putting up collections of porn pictures, where to prove you're not a robot stealing the pictures, they show you the word, you translate it for them, they sign up to the mailing list, and they give you a couple of porn pictures as payment. It's an extremely effective system for bypassing security. So there's an ongoing battle, particularly the mailing list people are involved in, trying to stop spam on the mailing lists. Documentation. You may have heard of documentation. There are rumours that this stuff exists somewhere. So, I mean, there are projects with fantastic documentation. PHP, I think, is one of the superb examples. It's well documented. There's a website for contributing notes on the documentation. You can see other people's notes and comments and suggestions. So you can go to a page thinking, why isn't this PHP working? You look it up on the website, you get the document, and you'll frequently find one of the notes says, by the way, it might not be obvious, but, and you think, oh, okay, that's what I've done wrong. You can actually have documentation which is worse than no documentation at all. It's quite hard to do, but we have managed it in the kernel team. We're slowly working on improving that, mostly by deleting large quantities of stuff which is just 10 years out of date. So this documentation is telling you how multiprocessing works until about a year ago, which was written for the 1.3 kernel and has been out of date for 5 years. And not just out of date, but completely wrong. So documentation is important. Documentation also needs translation. It needs people to read it and go, this documentation is wrong. This documentation is rubbish. Documentation is also fantastic QA. When my wife got involved in documentation, one of the things she found is she was documenting what everything did. They were like, what does this button do? Crunch. Oh. Right. Oh, crunch. Report bug. Nothing. In one case, report bug. Nothing happens. In the documentation, this button causes the program to crash. Wait. Bug gets fixed. But seriously, I mean, documentation, by trying everything, you're also doing QA and testing. And documenters are also likely to figure out things which don't make sense and hopefully stop the programmers. Not always. When you can have the hugest documentation team in the world, and you still get things like Microsoft Windows, where you press the start button to stop the computer. Or the Macintosh, where you drag your floppy disk to the trash can to eject it. Okay. When I put my floppy disk in the bin, that's not the usual thing I expect in the real world. Lawyers. Right. Now, not all lawyers are evil. This was quite a surprise some years ago. There's a lot of licensing work involved in free software. And behind the scenes, lawyers are involved in it. Not just in them, there's the big things, the GPL v3 negotiations, figuring out the right way to do licensing and stuff. Lots and lots of stuff that you don't see going on is things like the legal work required to figure out who owns all the bits of a piece of software before it can be open sourced. And you can be sure, for example, that with Sun open sourcing Java, a lot of lawyer hours have been used in figuring out which particular bits are owned by Sun. Sun have the rights to do this with, Sun need to go back to and sign agreements with, Sun need to rewrite, etc. And a lot of this is stuff they call due diligence. And the legal joke goes, what's due diligence? $150 an hour. Pro open source legal work. looking after projects, helping them when they get hit by frivolous lawsuits by people who want to put them out of business or just malicious or just a nuisance. Stopping them getting into trouble as well. So being able to answer questions like, I've reverse engineered this software this way. Is that something we can put in the kernel? Should it have been done differently? Well, hopefully people asking beforehand. And so things like the Broadcom driver. One team of people have been disassembling, documenting it. Another team, completely separate, write the code. You need lawyers involved in this to make sure you set it up in a legal fashion and a safe fashion initially. Enforcement work. Incredibly, we give people this software away with a few minor restrictions. And these people also could go and download BSD with no restrictions at all. And they pirate it. Well, it takes real effort to take free software and abuse it. But they do, on a large scale. And so there's a lot of enforcement work goes on, explaining to people that we have noticed that your product contains a copy of the Linux operating system. We would like to see the source code. And GPLviolations.org in Germany in particular has been very effective in enforcing judgments, including taking several companies to court who wouldn't settle and winning cases. Why these people didn't just use FreeBSD or NetBSD is completely and totally beyond me. But they use Linux, so we make sure they keep to the rules. Media. Yes, having free software people involved in reporting what's going on and stuff is terribly important. If you've seen the way the average computer media, or even worse, the general press reports, you will appreciate why there is a large vacuum that needs filling. The business press and the mainstream press have this problem that it's a company. Everything is a company. Don't understand this Linux thing. I know. We'll treat Linux as a company. Linus Torvalds is the CEO, and we'll write about it in that kind of way, and everything will work, and they'll understand. And that's what they do. The end result is being much of what they write is complete nonsense. So it's kind of like major fracture between open source developers is written around the kind of like, ooh, the head of marketing has left the project kind of thing. No, Eric Raymond made an idiot of himself, and he's no longer on our side. This is not the same thing as a company splitting up. It's somebody going off in a huff. So it's really important that things get covered from a technical point of view and not to actually explain what the stuff is really about, let people know what is going on. Because after all, if you're involved in free software, it's a collaborative project. Collaboration requires the information. You need to know what is happening. Otherwise, you will end up with 12 people writing CD player applets. Oh, wait. It didn't work then, did it? And whatever else the latest trendy thing to write is. And so the mass media doesn't really care about most of the detail. And the bits of the mass media that care don't have the space. It's not necessarily that they're not interested in open source. It's just that they have 137 words per week to allocate to computer news. And therefore, it's a bit hard to fit anything interesting in. Lobbyists, everybody's favourite people. Now, there are three kinds of lobbyists. There are good lobbyists, who are the people who believe what you do. There are the bad and evil lobbyists, who believe what the music industry and everybody else thinks. And there are professional lobbyists, who believe whatever they're paid to. Lobbying does matter. At the corporate level, people like IBM and stuff obviously do lobbying, and they go to the European Commission of people and say, this is stupid, or this is bad law, or you should do it this way, as do people like Microsoft. But there's a whole other bunch of people who really matter. Politicians don't get elected by corporations. They get funded by corporations. Right? Politicians are paid by corporations, elected by the people, and then their job is kind of to protect them from each other, or something like that anyway. It's one way of looking at the process anyway. And one of the great things about lobbying is all you actually have to be able to do is write a letter. In fact, if you're really lazy, thanks to things like Fax My MP, all you really have to be able to do is fill in a web form, hit submit, and answer an email. And having people actually tell politicians about things that they think matter, things like digital rights management, Microsoft abuse of monopolies, all of this kind of stuff really, really helps, especially when it comes from the people it affects. Because when a large company goes, Microsoft are being really, really evil about this, and it's kind of like, who are they? IBM. Aren't they a competitor with Microsoft? Your average politician is able to join the dots. And they may therefore deduce there might be other reasons for the complaining sometimes. When they get stuff from large numbers of end users saying, I can't do this, or your laws are stopping me doing things like watching DVDs I own, this is bad. Your laws are stopping me releasing software which filters flashing from DVDs for epileptics. It's a real world example. We've got software that could do that. Would allow epileptic people to watch a lot of DVD stuff they can't safely watch now with flashes in it. All the software does is to figure out when there's a lot of flashing and do something about it. Really, really simple software. But to release that software, we need to officially know all the DVD keys. So the European Copyright Directive effectively says, if you're epileptic, stuff you. So telling politicians about this kind of stuff really is important. Because most of them are not technical people. There are one or two exceptions. There are not many at the moment in Parliament who are particularly from a technical background. But most of them are, if you actually deal with them, they're quite bright. A lot of them are actually there because they believe in something, where something is not necessarily, can I have a peerage, here's my Visa card. And so they are useful people to deal with, to educate, and they are actually there to serve you. So make use of them. And that's really sort of the end of the list. And the last thing I want to notice about this, one of the things that happens in a lot of markets, telephone market is a beautiful example, is when large companies get threatened by new upcoming things, one of the things they love to do is say, safety, mutter, risk to the public, mutter, can't be trusted unless. Which is how the telecom industry pretty much shut everybody else out. By saying, you really, really ought to make sure that they meet this requirement, this requirement, this requirement. Because these people know, it's going to cost us profit, but that's going to stuff everybody else who's too small to carry the burden. So that's one of the reasons we have to be dealing with politicians, is to stop this kind of thing happening. Because we're seeing some of it already with things like wireless cards. You've got to be proprietary, definitely not lobbyists telling them, for the good of the public, protect the emergency services, can't have people actually writing their own code, can we? And similar things, people are trying to lobby, safety critical systems, should be binary only. Voting machines, definitely it'd be unthinkable to let people do things like look at voting machine code. They might find security flaws in it. And unless you educate politicians from a non-technical background, some of this sounds horribly reasonable. It's only when you explain to them that the security holes there will be found anyway, and you show them the video of the Chaos Computer Club playing chess on a secure voting machine, they begin to get the message. Oh yes, they actually did. It's actually on the Chaos Computer Club site with one of the voting machines they hacked. So it's all really, really important. So hopefully this gives you some idea of all the things that people can be doing if they're not programmers. There are lots of things out there. Marketing is a big one. Lobbying, talking to politicians, just telling people about the software and telling people honestly about the software. Because real marketing, long-term marketing, it does everything. It washes your dishes whiter than Windows. Real marketing is saying, this is what I do with it. This is what works. This is what I found I don't do with it. It's no good telling someone, Linux is fantastic, it's brilliant, it does everything if they're kind of hardcore Windows gamer. Because Linux isn't actually good for running hardcore Windows gaming. But telling you, I do all my internet with it, I do this with it, and then I boot back into Windows or use Windows with VMware and this, and then I play all my games this way. That is the kind of thing to tell people, because it's the truth. And you can only paper over kind of the details so much. And people who try and use software will eventually notice whether what you told them is approximately true or not. And if someone comes to Fedora or Ubuntu having been told that it does everything they need and it doesn't, they're much less likely to try it than even if you told them it's probably not for you at the moment. And then at some point in the future it may well be. So it is actually really important to tell people things as they really are if you're in the marketing business for the long term, which for free software we are. We're not trying to push something which 6 months later they've all sold, we'll never make another one again and we don't care, which is where this kind of, tell lies, fib about it, exaggerate thing comes. It's not like a film. once you've got everybody into a film, it doesn't really matter what the reviews say and everybody hated it. They've bought tickets, sodom. Right? The software thing is a kind of a more personal, long-term relationship between your computer, you, and the software on it. I think that's all I really wanted to say. So I don't know how we're doing for time, but hopefully we've got some room for questions. We've got plenty of time for questions. Or just about time for a talk on the innards of serial ATA. Yes. Do we have any questions?
So you spoke about lobbying politicians. Do you have any thoughts to share on lobbying other organisations like standardisation bodies or public service broadcasters?
If you're referring to the BBC and iPlayer, then on the advice of the lawyers who are involved in certain things I'm also involved in, I would prefer to say nothing more on the matter for the moment. Suffice to say the European Commission is aware of the issue and is considering it. In general, I've tried writing to organisations and I've got very mixed results. I've had everything from writing to an organisation and immediately getting an email back from their head of web development saying, "Oh, we're terribly sorry. We've been meaning to try this Firefox thing but not got round to it. I'll get that fixed tomorrow." To blank, no replies. For big organisations, if you try and get, for example, Yahoo or Amazon to fix something, it's interesting. And sometimes it's about actually knowing the people rather than knowing the company. The other area I've been involved with lobbying is being companies about things like documentation, free software for drivers. And that's really been a slow process, particularly with things like Taiwanese companies. Some of it's about culture. And it's really about understanding what their worries are. In those cases, building like a two-way dialogue. And that can actually be very hard to do. And sometimes you don't win. Sometimes you're kind of left in a position where, well, with NVIDIA some time ago, I was left anyway. I understood NVIDIA's position, NVIDIA understood my position. There was no middle ground. That's the way it works. What else to add? I suppose having a large number of people complain about something on a large site helps. We saw that recently with CNN. CNN in the US broke video playback on Linux. Interesting. Somebody reversing? Yes. Do we evacuate or laugh? Laugh. And one or two people mailed CNN and said, "Hey, look, your video service is broken," and nothing happened at all. After a large number of people had mailed and saying, "Hey, I can't work this stuff either," they sent emails out to people, to various people who applied, saying, "Yeah, we've looked at it, we've added some new code to the site, can you tell us if it now works?" So sometimes sufficient volume can help. But I don't think anyone can write you kind of this is the mini handbook of infiltrating and reprogramming organisations. Because they all work differently. So I don't know if that answers your question or not.
Well, yeah, it's a tough one.
Yeah.
I'm also thinking of standardisation bodies as well. The other thing that's
I have no vast experience of dealing with standards bodies and lobbying. I mean, my involvement with standards bodies has been pointing out things like inconsistencies at a technical level, that kind of stuff. So directly, I don't know. I mean, usually people don't lobby standards bodies. The OpenXML thing is kind of strange.
From hardware documentation point of view, is there light at the end of the tunnel?
Hardware documentation is a light at the end of the tunnel. I think there are several lights. One of them is that parts are becoming more and more standardized. Microsoft have done a wonderful thing for us inadvertently. Several years ago, they introduced this Windows Hardware Quality Lab stuff. And they made it really hard, really annoying, and really expensive to certify your driver. The practical upshot of this has been fantastic. People are writing drivers to the standards instead. Because it's now the case, well, we could do, and our driver might be 2% faster on a Windows benchmark if we did this clever thing. If we just follow whatever the USB standard is for this kind of device, it just works. We don't have to write a driver. We don't have to go through all this goddamn hardware certification, quality control, blah, 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 money, time stuff. So we'll ship a standards-based piece of hardware, which then works on Linux. So that's one of them. And going with the standardized, laptops now. Laptops used to be a nightmare in Linux. Every laptop was full of custom logic. Today, every laptop is Intel processor, Intel video, Intel wireless, Intel processor, Intel video, Broadcom wireless, and a few other combinations. Standard parts, which is fantastic news. In terms of vendors in general, we're doing pretty well on documentation. There are some companies which are still very, very hard to work with. Some companies who just appear not to care. Certain companies are very proprietary in their outlook initially. We are getting more and more contacts. This is also being helped by things like big vendors shipping Linux machines. Because if Dell says we want this server to be able to run Linux, Dell also has this habit, and people like HP and stuff saying, and we're going to be making 50,000 units of it. Can you supply us with an Ethernet card that will do? So all of a sudden there's a business instead. It's kind of like, if the Linux people have your documentation, you sell 50,000 more pieces of hardware to somebody. So all of a sudden there's a business case, which is great. The areas which are not doing so well, 3D graphics, where we've got great Intel support. NVIDIA are doing their own thing. There are various reasons NVIDIA are doing it in a proprietary way. They are at least trying to support Linux as best they can. I don't like what they're doing. I don't think what they're doing is legal. But they obviously do, and I think they're doing a pretty good job in supporting their product. ATI, God knows. AMD have been promising us for over a year now that things will be sorted out and wondrous stuff will happen. I don't believe a word of it. I think Bill Gates is more likely to start shipping Linux, quite frankly. Oh wait, maybe he already has done, hasn't he? We will see what happens. There is a lot of pressure on AMD there. But it's very, very slow, very, very painful. We're not seeing any progress. Even at the point where we've got kernel developers, AMD is saying, can you have a look at this bug? And there are kernel developers, I'm terribly sorry, I'm so busy reverse engineering my video card, I don't have time to look at your problem. And even that is apparently getting the message across. So I think generally it's pretty positive. A lot more vendors are willing to talk to us. Some years ago, when we still started, you talk to a hardware vendor and say, I want to do a Linux driver. And the first reply you got was, what's Linux? Right? We're past that stage. We're past the, and you want to release source code stage. We're now at the, are you worth our time? What is in it for us? What is the business case stage? Which is great, because that's a rational conversation you can have with the business people in these companies. Give me the documentation, it will work on Linux, nobody else's version of this card does, you will sell more cards. It's kind of, you don't have to be a programmer to make that decision, which helps. So I think it's broadly positive, not entirely. And there are always going to be hairy areas around things like HDTV, cable TV encryption, or things you'd expect.
Doesn't the argument you just presented about no one else's card works if you give us drivers, you'll sell more cards, mean that it's easy to get from sort of 0% to 50% in a particular market, but much harder to get from 50% to 100% because the last guy has almost no incentive? It's
actually what I find is it's normally easier to get from 0% to about 20%. Because what happens is that the big guy in the industry doesn't give a toss. He probably can't even be bothered to reply to your email. It's the small guy in the market, the guy who's being systematically crushed out of the Windows market by the market share of the opposition, who thinks, cross-platform, here's a new story, here's an opportunity. And they're often smaller companies more willing to take the risks. So yes, I find that. And the other thing you sometimes find is if you're trying to beat people together to get some kind of standard, you find everybody but the biggest player wants to be in on the standard. And you can actually look at it, there's actually sound economics behind that. You can actually sort of show all this in equations why this happens. So yes, it gets you started. But I don't care. Right? If I've got somebody who can provide the hardware which solves the problem, and they're only 10% of the Windows market, and their hardware works and their driver's good, I have no problem with them being 100% of the Linux market. And then the other side will have to wake up.
The problem with that arises if you're specifying the hardware and it wants to run Linux at the start. You're hoping that after sort of 3 weeks of surfing the web, needs to have the right parts in, and it doesn't. And
it's more normally specialist. There was a time what you're saying is true. I think it's now more normally specialist hardware we're dealing with where this kind of thing comes up. In a sense that most of it is either commoditized to a standard. So almost every serial ATA card from about 3 months ago onwards has a single standard. They're all based on AHCI. They speak a couple of interesting dialects of the standard in some cases, but there is a standard. And we're seeing that with USB, we're seeing it with most things, except 3D. Well, in the other parts of the market, also consolidated down to there are already 2 or 3 vendors. So you've only got to get one of the 3, and you've got a third of the market. But yeah, we're in that situation with video. Intel video, click bang, works. Anything else, fun.
you can't buy it on.
I keep telling Intel this. They don't seem to care. I think their view, presumably, is that nobody will be shipping plug-in video cards and normal machines soon. Right.
Coming back to documentation, that's a problem in the proprietary industry as much as it is in open source, and it's always been a problem.
Oh yes.
And it doesn't seem to be getting any better. But is the open source community any better placed to be able to do it better?
To answer that question, you would need to understand why documentation in software is really, really bad. And I've worked in the software industry for an embarrassingly long number of years now, and I still don't understand why the problem is there. Especially the proprietary, it ought to be really simple. You hire someone, you tell them, write documentation for this. Or you take a program, write documentation when you've written this code, or we fire you. But somehow we still have utterly dreadful documentation. And yeah, I've worked in proprietary companies where we had no documentation for the code at all. Where we found a security hole, and the company couldn't actually work out which of its other products had the same piece of code copied into it without testing them all. So it's not just a free software disease. How you improve it, I don't know, other than partly by telling people who are working on a project, go look at php.net and ask yourself why your project doesn't look like that. And in the case of the kernel, give us time, we know about it. It may be quite a while before we get to that standard.
With end-user documentation, which seems even worse than anything, isn't that the case to actually write that first? Before you even look at
Well, if you want to know roughly how the software works, but that assumes you design the software and write it. Whereas particularly in free software and in real-world proprietary software, as taught outside of university software engineering classes, you write the software first. Everybody knows that. And it's usually the way it happens, which makes it hard. One thing I have found, which is very interesting, is a lot of the best user documentation, you look at things like Fedora documentation, Ubuntu documentation stuff, a lot of the best user documentation are things like how I get my NVIDIA card to work, why doesn't my Broadcom wireless work, all this kind of stuff is written by end users. And I think partly that's because they've at the same kind of level of understanding and thinking, they remember to say all the things that the programmer forgot to tell you. Like, for example, that you need to put the file in the same directory as this or whatever. So there is documentation coming about that way. What I don't know about that and what I see as a problem increasingly is a lot of this documentation is in wiki format, which is great if you can find it. But a wiki is kind of a write and pray you can find it later approach to documentation. And I don't know what's going to happen in the longer term, but how do you organise this stuff? I don't know what people like Ubuntu are doing in the long term about planning for that. But certainly in the Fedora case, I think one of the things that people have got to start thinking about is how do I make sure you can find all this stuff next year? But for the general answer, I really don't know, A, why the documentation is so bad, or B, why it's so hard to fix it. I also don't know if it's the same in other industries. I don't know if you've got people here who work in non-computing industries who have comments about documentation. Apparently.
Well, no, not really, but I still have a comment about
Yeah.
documentation. I think often there is great documentation, it's just the lack of good documentation and the budget creates an aftermarket for good documentation. So
Yes.
even as good as PHP's documentation is,
There's still PHP
still,
books.
the best
Bookshelf.
documentation is all of the books that you can get on the
Yeah.
O'Reilly bookshop or whatever, and or even the sort of Ruby approach of we'll slap up a few video demos, get everyone excited, and then everyone will jump in and write books.
Yeah.
So
I suppose that's perhaps that's one answer to the question why open source documentation is so bad. Is that every time somebody writes good stuff, I rarely pay them to print it. I don't know. You want back there?
The whole idea of testing by releasing versions that then hopefully lots of people test is great, as you say, it's testing the really common things. The thing it doesn't seem to catch, and which I've not seen anybody get a solution to, is making sure that things that aren't yet common but will be in 6 months are tested properly. Things like, when file systems suddenly get over n terabyte or something, they aren't yet, in a year everybody will have them, or when a new type of piece of hardware turns up. Nobody tests it when everything's new. It only gets really heavily tested when lots of tests is time.
Actually, to be honest, file systems are a bad example because there are people who have very, very large, expensive collections of data who pay to make sure file system stuff does get tested that size already. But I take the general point. There are two things, I think, there. One of which is things that don't happen very often don't get tested very often. This is particularly things like error cases. There are a couple of things you can do about that. One of them is you write your code in such a fashion that the error cases are very cleanly handled, or you structure it that way in the programming language. The other one, if you're working in something like C, so therefore it isn't particularly clean, is that we use validation tools. And on things like the kernel, we have got validation tools that can do things like spot a function where a lock is taken but not released on some paths, this kind of thing. And that has turned up tons of stuff, particularly in error cases, stuff which essentially does not happen. But if had it ever happened, it would have broken. And we've got things like the lock validator now as well, which is intended to find lock ordering bugs which may never really trigger in the real world. So we're trying to do some of that. There's also what people call fuzz testing. So you take a valid file system, just change a few bits, mount it, unmount it, and keep doing this until the computer crashes. We do a similar thing for just basic operating system testing. There's a wonderful program written in the 1980s which was called Crash Me. It's a very simple idea. Generate a list of random numbers, run them, catch the exceptions, repeat. And you just leave it running for a few weeks. And this has found processor bugs, kernel bugs, all sorts of things. Because eventually the random weirdness it's looking for happens. So, yeah, some of that is tool-based. And the great thing about that, that's the kind of testing you can automate. So it's the kind of testing people like Red Hat have got running continuing in the background. It's the well-meaning, well-intentioned, I was following the instructions and it broke kind of stuff. Which is the stuff which is sometimes most important to test and which the user testing produces the best results for. So yes. Yeah.
What do you think about the FRO GPR?
I've only ever very vaguely glanced at it, so I don't know.
How do you do that kind of testing on hardware?
Happily, I don't have to. I get the results occasionally where people haven't. The usual answer is you ship it. One of the problems with device driver writing, particularly reverse engineering, is you don't know all the funny cases. But I have, for example, had a video card whose 2D rectangle draw function caused the card to lock up, requiring power cycling. And only after several hours of staring at the code did the person involved in the driver realise that this is a known errata and you're supposed to draw two triangles. Right? So hardware vendors do ship some really dreadful stuff and paper over it in software. And that can be very hard to deal with. Have a look at just have a look at the errata for like a modern Intel processor. And they do their best to verify it, but once they've shipped it, they just start documenting. In software, you'll need to do this fix, that fix, and design the hardware accordingly. How they do all the fine stuff, I don't know. When you think about the complexity of an Intel CPU, for example, and the number of bugs it has, and then you take the equivalently large size software project and you look at the number of bugs that has, it's abundantly obvious that they have something to teach us. But the actual innards of hardware testing is not an area I've worked in, or an area I particularly want to work in. So at least in software, when you make a mistake, it only costs you a recompile. You don't have to go and make a new version of the chip every time you screw up.
That's why.
Yeah.
Right, that's it, everyone. Thanks so much, Ellen.